All right, let's go ahead and move on to the second half of 2.1. For this set of notes, we are going to translate and solve equations. All right, so we're going to be using what we learned in Unit 1 in terms of writing these algebraic expressions from word-to-word phrases. But what's different this time around is that we're going to be writing equations and then solving them. Okay, so this is kind of going to get you ready for when we get to these full-out word problems later on in the unit. All right, so we take a look at the first statement. The sum of a number x and 8 is 14. The first thing we see there is the word sum, which we know translates into an addition. So we're going to be using the plus sign in what we write here. And usually when we add, we're going to be adding at least a couple things. So here it looks like we're going to be adding some random number x and 8. Now what's going to be different this time around, as I said, is that we're writing equations. Now usually where you see the word is, right, we can safely translate that into an equal sign. Now I said usually that's the case, so we're going to find out when we get to the word problems that sometimes, right, where we put the equal sign may not be as obvious as looking for the word is, right? But again, we'll get there when we get there, right? All right, so let's go ahead and write our equation. So we need to add some number x and 8, and we want that sum to be equal to 14. All right, so there's our equation for part A. So now let's go ahead and solve it. So again, we're going to undo operations to isolate the variable. So we're going to subtract 8 from both sides. We have x is equal to 6. Moving on to part B, the product of negative 6 and a number x is 18. All right, so again, when we think of product, we think of multiplication. So again, we're going to be using our dot as a multiplication. Right? Usually when we multiply, we need at least 2 things to multiply. So here we are going to be multiplying negative 6 and x. There's the is. So that's going to translate into an equal sign. All right, so the product of negative 6 and a number x. So again, we could do negative 6 dot x or just negative 6x. Right? We don't need to write a symbol, right? In these algebraic expressions, if we do not see a symbol between a number and a variable or other variables, we can safe to assume it's multiplication. There's our equal sign and 18. So the product of negative 6 and a number x is 18. All right, so now that we have our now we have our equation. Right, I'm going to undo the operation since it's multiplication. We are going to do the inverse operation of that, which is division. So we're going to divide both sides by negative 6. And we get x is equal to negative 3. Part C, 8 less than a number is negative 12. 8 less than a number, n, is negative 12. All right, so we see the words less than, so we know it's a subtraction. Here is, so we know that's where we're going to be equal sign. All right, so we know we're going to do a subtraction here. All right, we see 8 and this number n. Again, recall from Unit 1, if we see the words less than, the order in which we write it is going to be flip-flop from what we read it. All right, so we're going to write that as n minus 8 equals negative 12. All right. So now we go ahead and solve for n. We're going to undo the operation, so we're going to do the inverse. And we get n is equal to negative 4. quotient. The quotient of a number x and 9 is -6. All right, so quotient means we're going to do some division. Right? What we're going to be dividing is x and 9 translates into the equal sign. All right, so again, when we do division, it's important, again, we do not use the old-fashioned division symbol, right? The line with the 2 dots, right? When we do division, we're always going to be using the fraction bar. The order in which you read it in a problem like this is how you're going to write it with respect to the fraction bar. Since we see a number x first, that's going to go on top. 9 is second, so that's going to go in the denominator. Right? So x is in the numerator, 9 is in the denominator because of the order in which we read. Equals -6. All right, so now that we have our equation written, let's go ahead and undo operations. Since it's division by 9, we want to do the inverse, which means we're going to multiply by 9. So here we have x is equal to -54. Part E, the area of a rectangle is 54 inches squared. It says find the value of x. So we want to recall that the formula for area of a rectangle, oh, I think I said square, right? The area of a rectangle is 54 inches squared. It says find the value of x. Recall the formula for rectangle. For area of a rectangle is A equals length times width. Area equals length times width. All right, so we're going to use that formula. Right, so since we know that that's the area, right, so that's our A. So we're going to plug 54 in for A. The length, that's going to be 12. So we're going to plug 12 in for L. And that's going to leave X for W. Okay, so that's going to be multiplied right here. Oop, we want X, not W. All right, so here we're using our formula for area, our known formula for area, to write this equation. All right, so solve for X. We're going to undo the operation. I'm going to do the inverse, which is divide by 12. Okay, so now 54 doesn't go in, or 12 doesn't go into 54 evenly. All right, so we're going to need our calculator for this one. Now, I did say the other day in terms of, right, what form your answer should be in, right? Again, since 12 doesn't go into 54 evenly, right? Now, for this one, right, we are allowed to use a decimal as our answer. It's because it is associated with a word problem, okay? So in situations, right, where we are solving an equation that is associated with a word problem like this one, right, area of a rectangle, it is okay to go ahead and give me decimal answers when you solve your equation. All right, so now we're going to finish up today solving these, what are called literal equations. So what literal equations are equations that have more than one variable in it. So now it's important to understand, right, that we're only going to be asked to solve for one of those variables that is in the equation. And it's also important to understand that the way you're going to solve for that one variable, even though there are other variables in the equation, is that you are still going to follow the path that we talked about. When it comes to solving an equation for a variable, you're going to undo the operations. You're going to do the inverse of whatever operation's being done to that variable. So let's take a look at the first example here. We have W equals F times D. Right? Again, it's multiplication since we do not see a symbol between the F and the D. So again, it's W equals F times D. Right? And we want to solve for F. Right? So that means we want to get F by itself. So to do that, we need to get rid of D. Well, again, when we read this, we said it was F times D. And because it's multiplication, we know that the way we're going to get rid of that D is to do the inverse. And the inverse of multiplication is division. So we are going to divide both sides by D. That's going to get F by itself. Now what's left on the other side, again, it's going to be a little weird, right? Because, right, these are letters, these are variables, right? We cannot literally, right, write down like a single number answer, right? For F, it's just going to be F is equal to W over D. W divided by D. Part B, we have this formula of R equals R sub 1 plus R sub 2. And we need to solve for R sub 2. All right, so that means we want to get R sub 2 by itself. All right, so what I like to do sometimes is I like to kind of box in the variable that I want to isolate. Okay, so R sub 2, we want to solve for this variable. So that means R sub 1 needs to go. All right, since R sub 1 is being added to R sub 2, we know we need to do the inverse to get rid of that R sub 1, which means we need to subtract. So we're going to subtract R sub 1 from both sides of the equation. So on this side, the right side, the R sub 1's go away, leaving us with R sub 2. And on the other side, again, these are variables. So unless we have like terms, all we're writing is something like this, R minus R sub 1. So there's our solution for R sub 2. Part C, we have A equals L times W. We want to solve for W. Okay, so again, to solve for W, that means we need to get rid of L. And since L is being multiplied to W, we are going to divide it out. To do the one side, we have to do to the other. So on the left side, we get W by itself. And on the left side, A divided by L. All right? All right, so that's it for today. Go ahead and move on to the homework. If you have any questions, please let me know.